The field of cloud computing is growing exponentially, leading to a surge in demand for professionals in this area. This video is designed to prepare you for your next cloud computing interview by presenting the top 25 questions commonly asked in this industry. Each question in this video comes with a comprehensive answer, ensuring you're well equipped for your interview. Whether you're a seasoned professional or a budding enthusiast, these questions and answers will help you gain a solid understanding of cloud computing. 1. What is cloud computing? Cloud computing is an innovative technology that provides on-demand delivery of computing services over the internet. These services include storage, databases, servers, software, analytics, and intelligence. With cloud computing, you can access all these resources through the internet without having to own or maintain the physical infrastructure. This approach offers flexible resources, economies of scale, and you only pay for the services you use. This helps in reducing operating costs, running infrastructure more efficiently, and scaling as your business needs change. The technology's name comes from the common use of a cloud-shaped symbol as an abstraction for the complex infrastructure it contains in system diagrams. 2. What are the different service models of cloud computing? Cloud computing offers three primary service models: infrastructure as a service, IaaS, platform as a service, PaaS, and software as a service, SaaS. IaaS provides users with access to virtualized hardware resources, such as servers, storage, and networking capabilities. Users can customize their infrastructure according to their specific needs and pay only for the resources they utilize. Amazon Web Services, AWS, and Google Cloud are examples of IaaS providers. PaaS offers a complete development and deployment environment in the cloud. It includes infrastructure, middleware, development tools, database management systems, and more. It allows developers to create, test, and deploy software applications without worrying about underlying infrastructure. Examples of PaaS providers are Heroku and Microsoft Azure. SaaS delivers software applications over the internet on a subscription basis. The SaaS provider manages all the underlying infrastructure, middleware, app software, and app data. Examples of SaaS providers are Google Workspace and Salesforce. 3. What are the benefits of using cloud computing? Cloud computing boasts numerous advantages for businesses and individual users. The most significant benefit is cost effectiveness. With cloud computing, you can save substantial capital costs with zero in-house server storage and application requirements. The direct costs of buying and managing software is eliminated because you only have to pay for what you use. Additionally, there is improved accessibility as you have access to your data anywhere that there's an internet connection. Cloud computing promotes efficiency by allowing for real-time collaboration among a workforce. It offers flexibility in the sense that it can be turned up, down, or off depending upon circumstances. For example, a sales promotion might be wildly popular, and capacity can be added quickly to avoid crashing servers and losing sales. Cloud computing offers a greater level of security than traditional systems, as providers are able to devote vast resources to solving security issues that many customers cannot afford. Lastly, it contributes to environmental sustainability by reducing energy consumption. 4. How does cloud computing differ from traditional computing? Cloud computing differs from traditional computing in several key ways. Firstly, cloud computing provides on-demand access to a shared pool of resources, such as servers, storage, applications, and services. This contrasts with traditional computing, where resources are dedicated and must be manually added or removed. Secondly, cloud computing is scalable and can easily adjust to changes in demand, whereas traditional computing requires significant effort and cost to change capacity. Lastly, cloud computing uses a pay-as-you-go model, only charging for the resources used, whereas traditional computing often requires upfront capital expenditure and ongoing maintenance costs. In comparison to traditional computing, cloud computing offers greater flexibility, scalability, and cost efficiency. However, it also presents unique challenges, such as data privacy and security concerns, that must be carefully managed. 5. What is a virtual machine, VM? A virtual machine, VM, is an emulation of a computer system that operates based on the architecture and functions of a real or physical computer. Their implementation involves specialized software, called a hypervisor, that separates the machine's physical hardware from the computing environment, where the VM is created. This enables a single machine to run multiple VMs, each with its own operating system, OS, and applications, as if they were separate, physical computers. VMs are fundamental to cloud computing as they provide the ability to scale services according to the demand, ensuring efficient use of resources. For example, an organization could run an older software on a VM that replicates an older system, without having to maintain the older hardware that the software was designed to run on. VMS provide the ability to run software and applications on a wide range of hardware, making them highly flexible and cost-effective. 6. Define the term hybrid cloud. Hybrid cloud refers to a computing environment which combines a public cloud and a private cloud by allowing data and applications to be shared between them. When computing and processing demand fluctuates, an organization may opt to have some resources on premises and others in the cloud. This provides businesses greater flexibility and more data deployment options by taking advantage of all the benefits of both in-house and cloud technology. In essence, hybrid cloud allows companies to seamlessly scale their on-premises infrastructure up to the cloud to handle any overflow without giving third-party data centers access to the entirety of their data. This means that a company can maintain the control of an on-premises private cloud, while still enjoying the advantages of public cloud services. Hybrid cloud is particularly valuable for dynamic or highly changeable workloads. 7. What is the significance of APIs in cloud computing? APIs, or Application Programming Interfaces, play a crucial role in cloud computing. They act as a bridge between different software applications, allowing them to communicate and work together. In the context of cloud computing, APIs are often used to automate tasks, such as creating, managing, or scaling resources. For example, an API might allow a developer to programmatically create new virtual machines or storage buckets, without having to manually log into the cloud provider's console and perform these tasks by hand. APIs also enable the integration of cloud services with other systems and applications. This can enhance the functionality and efficiency of a company's IT infrastructure. It's also worth noting that APIs can be used to abstract the underlying infrastructure, making it easier for developers to work with the cloud without needing to understand all of its technical details. 8. Can you explain what a cloud service provider, CSP, is? A cloud service provider, CSP, is a third-party company that offers a wide range of computing services and solutions via the internet. These services primarily fall under three categories: infrastructure as a service, IaaS, platform as a service, PaaS, and software as a service. SaaS, CSPs enable businesses to use computing resources, such as virtual machines, storage, or applications, without the need to directly manage and maintain the computing infrastructure. They are responsible for ensuring uptime, security, and data protection while providing scalability and efficiency benefits. A CSP, or cloud service provider, is essentially a company that provides various technology services over the internet. These services often encompass storage, networking, and computing services. When a business engages with a CSP, it rents these services instead of owning and maintaining its own physical infrastructure. The benefits are huge: cost-effectiveness, scalability, and accessibility. The user can access their data or services from anywhere, as everything is stored in the cloud. Services given by CSPs often fall into three categories: infrastructure as a service, IaaS, platform as a service, PaaS, and software as a service, SaaS. AWS, Amazon Web Services, Google Cloud, and Microsoft Azure are examples of popular CSPs. 9. What is the purpose of a content delivery network, CDN? A content delivery network, CDN, is an essential component in the realm of internet space. Its primary purpose is to provide a swift and efficient delivery of internet content to users spread across diverse geographical locations. It achieves this by strategically positioning servers in various locations around the globe, thus ensuring that users have faster and reliable access to the content they desire. This not only enhances the user experience but also reduces the risk of network congestion. Additionally, CDNs provide security from malicious attacks and ensure high availability and redundancy. In today's digital era, where user experience plays a decisive role in the success of online businesses, the need for CDNs becomes more crucial. Whether it's loading a web page, watching a video, or downloading files, CDNs help to accelerate these operations and thereby increase user satisfaction. The use of a CDN can also translate to cost savings for the business. By caching content at the edge of the network, the amount of data that an origin server must provide is significantly reduced, thus decreasing hosting costs. 10. What are the main deployment models for cloud computing? Cloud computing can be deployed using various models, each designed to cater to specific needs and scenarios. Here are the four main deployment models. 1. Public cloud. Services are delivered over the public internet and available to anyone who wishes to purchase them. The cloud resources like servers, storage are owned and operated by a third-party cloud service provider. Example: Amazon Web Services. 2. AWS, Google Cloud Platform. 3. Private cloud. The services and infrastructure are maintained on a private network. These clouds offer the greatest level of security and control, but they require the company to still purchase and maintain all the software and infrastructure. 4. Hybrid cloud. This model combines public and private clouds, allowing data and applications to be shared between them. It gives businesses greater flexibility, more deployment options, and helps optimize existing infrastructure, security, and compliance. 5. Community cloud. In this model, the cloud infrastructure is shared among several organizations from a specific community with common concerns, security, compliance, jurisdiction, etc., whether managed internally or by a third party and hosted internally or externally. So, the deployment model to be chosen depends on the specific needs and goals of an organization. 11. What is infrastructure as code, IaaC? Infrastructure as code, IaaC, is a method that provides administrators with a way of managing and provisioning computing infrastructure through machine-readable script files, rather than using interactive configuration tools. The scripts define and provide data center infrastructure in a high-level language that looks like the code that typical software developers might use. IaaC can simplify the process of managing servers and can help reduce the possibility of human error. By using IaaC, developers can use the same language, processes, and tools they use for application code. This method can promote consistency and efficiency. It is used to control the hardware virtualization often associated with the infrastructure as a service, IaaS, but it can also be used for arranging the software as a service, SaaS, offerings. Using IaaC, the infrastructure needed to run applications can be automatically managed, making it easier for organizations to scale and deploy applications more quickly. Therefore, IaaC has become an important part of DevOps practices. It automates the process, thereby reducing the scope of errors and increasing efficiency in the deployment process. Tools like Chef, Puppet, Ansible, and Terraform are often used for implementing IaaC practices. 12. Explain the concept of microservices in relation to cloud computing. Microservices, also known as the microservices architecture, is an architectural style that structures an application as a collection of services that are highly maintainable and testable, loosely coupled, independently deployable, organized around business capabilities, and can be developed by small, autonomous teams. In the context of cloud computing, microservices play a crucial role in developing applications that are robust, scalable, and easy to manage. Each microservice in a cloud-based application can be deployed, upgraded, scaled, and restarted independently of all sibling services in the application. This not only makes the application more resilient but also provides a higher level of agility and speed in responding to the ever-evolving needs of the business. Microservices communicate with each other using well-defined APIs and protocols, typically HTTP, REST with JSON or protobuf. The microservices architecture is ideal for the continuous delivery and deployment of large, complex applications. While monolithic architectures are considered to be simpler and more straightforward, microservices offer organizations a high level of flexibility and scalability, which is essential for cloud-based applications. 13. What is serverless computing? Serverless computing is a cloud computing model where the cloud service provider dynamically manages the provision and allocation of servers. Unlike traditional cloud computing, where you rent space on a server, serverless computing platforms allow developers to write and deploy code without the hassle of worrying about the underlying infrastructure. With serverless applications, companies can bring products to market faster and more efficiently. This model is event-driven, meaning applications are not always running and only trigger when a specific function or command is initiated. This can lead to significant cost savings as you only pay for the compute time you consume. 14. How do you ensure data security in a cloud environment? Data security in a cloud environment can be ensured through various strategies. Implementing robust access controls is one of the primary measures. This includes setting up strong passwords, two-factor authentication, and limiting data access to only necessary individuals. Encrypting data, both at rest and in transit, adds another layer of security. Regular data backups are also essential to prevent loss due to potential threats or system failures. It's also crucial to choose a reputable cloud service provider that prioritizes security and complies with all necessary regulations and standards. Keeping all software, systems, and applications updated can further protect against potential vulnerabilities. Finally, conducting regular security audits and vulnerability assessments can help identify any areas of concern and allow for prompt action. 15. What are the challenges associated with cloud migration? The process of shifting data, applications, and other business elements from an on-site computer to a cloud-based platform is referred to as cloud migration. While this process presents numerous benefits, it also poses a set of unique challenges. The first major challenge is the potential for data loss during the transition. Ensuring data integrity is a crucial part of this process. Another significant challenge is the need to train staff on new systems and processes, which can take a significant amount of time and resources. A further complication to the migration process is the task of ensuring all applications remain compatible in the new environment. Finally, security concerns are always a factor when dealing with cloud-based platforms, as data breaches and other cyber threats pose a significant risk. Cloud migration also involves significant planning and strategy in order to ensure a smooth transition. This includes the need to understand and prepare for the cost implications associated with moving to a cloud-based platform. Additionally, businesses must carefully evaluate their cloud provider to ensure they can meet the necessary security and compliance requirements. This can be a complex process, requiring in-depth knowledge and expertise in cloud technologies. Despite these challenges, with careful planning and execution, cloud migration can provide significant benefits to businesses, including increased flexibility, cost savings, and access to innovative cloud-based services. 16. Define elasticity in cloud computing. Elasticity refers to the ability of cloud services to quickly expand or shrink computing resources in response to changes in application demand. It is one of the key benefits of cloud computing that differentiates it from traditional computing. Elasticity ensures that applications always have the right amount of resources at their disposal, thus enhancing efficiency and reducing costs. In cloud computing, elasticity is offered for a wide range of resources, including computational power, storage, and bandwidth. It enables businesses to adjust their IT infrastructure based on real-time needs without any upfront investment in physical assets. For instance, an e-commerce website may need additional servers during peak shopping seasons to accommodate increased traffic and prevent website crashes. With cloud elasticity, the business can easily scale up its server capacity during this period and scale it back down once the demand decreases. Elasticity in cloud computing is a significant feature that allows businesses to efficiently manage their resources and maintain high performance. This capability to scale resources up or down in response to demand ensures that businesses can handle workload spikes without over-provisioning resources. Therefore, elasticity not only enhances performance but also optimizes cost by ensuring that businesses pay only for the resources they use. 17. What is a container orchestration platform? Name an example. Container orchestration platforms are crucial in managing the life cycles of containers, especially in large, dynamic environments. They enable users to control and automate many tasks including deployment, scaling, and networking of containers. It can be used to manage services within clusters, ensure failover in case of machine failure, and provide hardware and software optimizations. One of the most popular examples of a container orchestration platform is Kubernetes. Container orchestration platforms are a key piece of technology in the modern, cloud-native development landscape. At its core, these platforms assist in automating and managing the lifecycle of a container, from deployment to scaling, and even decommissioning. They are particularly useful in large-scale environments where there are hundreds, if not thousands, of containers in operation at any given moment. A key function of a container orchestration platform is to manage services within clusters. This includes ensuring that the same version of a service is running across all nodes, that failovers are handled gracefully in the event of a machine or service failure, and that resources are allocated efficiently. One of the most well-known and widely used examples of a container orchestration platform is Kubernetes. Developed by Google, Kubernetes has become the de facto standard for container orchestration, largely due to its robust feature set, active open-source community, and deep integrations with other key pieces of the cloud-native stack. 18. How does load balancing work in cloud environments? Load balancing within cloud environments is a strategic technique for distributing workloads across different servers or computing resources. This helps to ensure that no single server becomes overwhelmed, thus maintaining the efficiency and reliability of applications. The load balancer acts as a sort of traffic cop, directing client requests across all servers capable of fulfilling those requests in a way that maximizes speed and capacity utilization and ensures that no one server is overworked, which could degrade performance. If a single server goes down, the load balancer redirects traffic to the remaining online servers. When a new server is added to the server group, the load balancer automatically starts to send requests to it. In cloud environments, load balancing can be either software-based or hardware-based. Software load balancers are generally more flexible and easier to manage, particularly in a cloud environment. In terms of cloud service models, load balancing is mostly associated with infrastructure as a service, IaaS. However, it can also be used in both platform as a service, PaaS, and software as a service, SaaS, models. 19. What are some common cloud-enabling technologies? Cloud-enabling technologies are crucial in today's digital era, as they provide the backbone for cloud computing. They serve as the tools and applications that facilitate cloud services and operations. Some common cloud-enabling technologies include virtualization, service-oriented architecture, SOA, grid computing, and utility computing. Virtualization is a technology that separates hardware and software layers, allowing multiple users to share a single physical instance of a resource or an application. Service-oriented architecture, SOA, is a method for systems development and integration where functionality is grouped around business processes and packaged as interoperable services. Grid computing is a type of computing in which a virtual supercomputer is composed of a cluster of networked, loosely coupled computers, working together to perform large tasks. Utility computing involves the renting of computing resources such as hardware, software, and network bandwidth on a pay-per-use basis. Remember, the particular technology a business chooses to implement will depend on its specific needs, budget, and long-term goals. Cloud-enabling technologies play a pivotal role in supporting and facilitating the operations of cloud computing. These technologies come in various forms, each with its own set of capabilities and benefits. For instance, virtualization technology allows for the creation of virtual versions of physical hardware, thereby increasing efficiency and scalability. On the other hand, service-oriented architecture, SOA, supports the delivery of services using a set of protocols, facilitating interoperability between disparate systems. Grid computing serves to combine computing resources from multiple domains to reach a common goal, while utility computing offers computing resources as a metered service, similar to a public utility. By leveraging these technologies, organizations can optimize their cloud operations and services, achieving greater flexibility, scalability, and cost efficiency. 20. Explain the difference between block storage and object storage in the cloud. Block storage and object storage are two types of data storage in the cloud. Block storage divides data into blocks, which are stored in separate pieces, each with a unique identifier. This type of storage is effective for traditional database systems, where data is stored in structured blocks and read in chunks. On the other hand, object storage stores data as objects, each with a unique identifier, additional metadata, and no hierarchical structure. This makes it efficient for storing unstructured data like music, photos, or video files. Object storage is highly scalable and cost-effective for large datasets because you can add data on an as-needed basis. New technologies, like big data analytics and IoT, rely more on object storage because they deal with unstructured data. However, block storage is still critical for many enterprise applications that require consistent, low-latency access to data. Each type of storage has its strengths and weaknesses, and the choice between block and object storage depends on the use case. 21. What is AWS Lambda, and how does it function? AWS Lambda is an event-driven computing service that runs your code in response to events and automatically manages the computing resources for you, making it easy to build applications that respond quickly to new information. It works by executing your code only when needed and scales automatically, from a few requests per day to thousands per second. You pay only for the compute time you consume. There is no charge when your code is not running. With AWS Lambda, you can run code for virtually any type of application or backend service, all with zero administration. Just upload your code and Lambda takes care of everything required to run and scale your code with high availability. You can set up your code to automatically trigger from other AWS services or call it directly from any web or mobile app. AWS Lambda supports languages like Node, JS, Java, C#, Go and Python, and the code packages can be deployed in zip or jar files. 22. How would you troubleshoot high CPU usage on a cloud instance? Troubleshooting high CPU usage involves a number of steps. First, you need to identify the processes that are consuming the most CPU resources. This can be done using monitoring tools provided by the cloud service provider or third-party applications. Secondly, analyze the identified processes to determine whether they are necessary for the system's operation. In case the process is not needed, it can be stopped or killed. However, if it's vital to the system's operation, then you may need to optimize it. This could involve rewriting the code or implementing caching or indexing to reduce its load on the CPU. Another approach is to scale the system either vertically, adding more CPU resources to the existing instance, or horizontally, distributing the workload across multiple instances to manage high CPU usage. Lastly, it is important to implement a robust monitoring system to detect and alert when CPU usage is approaching the limit. This allows for proactive management of resources to prevent high CPU usage before it impacts system performance. 23. What is edge computing, and why is it becoming important? Edge computing refers to the method of optimizing cloud computing systems by performing data processing at the edge of the network, near the source of the data. This reduces the amount of data that needs to be transported across the network, resulting in improved response times and saved bandwidth. As we continue to generate more data through various devices and applications, the need for speed, efficiency, and real-time processing has increased. Edge computing has become increasingly important as it addresses these needs. By processing data closer to its source, edge computing effectively reduces latency and provides real-time insights, making it particularly beneficial for industries like manufacturing, healthcare, telecommunications, and finance where quick decision-making is crucial. Additionally, edge computing also enhances security as data is decentralized, decreasing the potential impact of a single point of failure. In the era of Internet of Things, IoT, where billions of devices are connected, edge computing paves the way for faster and more efficient processes, making it not just a trend, but a necessity in our increasingly connected world. 24. Describe what rate limiting means in API management within cloud services. Rate limiting is a vital technique used in API management to control the number of requests a user can send to a cloud service within a specific timeframe. This is typically used to prevent abuse, manage resource allocation, and maintain the quality of service across all users. With rate limiting, the service provider sets a limit on the frequency of API calls from a particular user or IP address. If a user exceeds this limit, the server will send a response indicating that the rate limit has been exceeded. This technique is especially important in cloud services, as it helps to protect the system from being overwhelmed by a sudden surge in demand, ensuring smooth operation and preventing service disruptions. 25. What are some major compliance issues related to cloud computing? Data privacy and security represent significant compliance issues in cloud computing. In particular, adherence to regional regulations like the GDPR in Europe or the CCPA in California is crucial for avoiding hefty fines. Businesses must ensure that their cloud service providers are compliant with these regulations to protect user data adequately. Another challenge lies in adhering to industry-specific regulations. For instance, businesses in the healthcare sector must conform to HIPAA, Health Insurance Portability and Accountability Act, standards, which dictate how patient information can be stored and processed. Similarly, financial institutions must follow regulations like the Payment Card Industry Data Security Standard, PCI-DSS, which sets guidelines for credit card information storage. Furthermore, there's the risk of non-compliance due to shared responsibility. While cloud providers are responsible for the infrastructure security, users are often responsible for securing their data within that infrastructure. Misunderstanding this division of responsibility can lead to non-compliance. Lastly, data residency laws pose a challenge. These laws require certain types of data to reside within the country of the data owner. Businesses must ensure they understand and abide by these laws when utilizing cloud services to avoid non-compliance. In proactively addressing these compliance challenges, businesses can ensure they are making the most of the cloud while staying within legal and industry guidelines. In closing, these top 25 cloud computing interview questions and answers are designed to help you prepare for your upcoming job interview. They encompass various aspects of cloud computing such as cloud architecture, security, services, and deployment models, among others. By understanding these concepts and being able to articulate your knowledge during an interview, you stand a greater chance of securing your dream job in this field. We hope you found this information helpful. If you liked this video, please hit the like button and don't forget to subscribe to our channel for more such content. Thank you for watching.